anyone want to open up or? Yes.
So anything else you want to say about AOP other than
Oh, anything else I want to say about AOP? There it is, right off the bat, eh? So AOP, for those of you who don't know, aspect-oriented programming, and I get asked this question on and off. At this point, I'm sort of in wait-and-see mode. I would, so call me a skeptic, if you will. I think there's some interesting things you can do with AOP. The prototypical example always comes up is logging or instrumentation or debugging or monitoring, and all of those I think are interesting uses, but I worry about it as a general purpose programming discipline because, I mean, I imagine myself writing code where, you know, I know precisely where control comes in and where it goes out, and what goes in between is code I wrote unless I called something else. But with aspect-oriented programming, anyone can put stuff anywhere they want. And I just don't see how, at a large scale, you reason about code in that way. And indeed, when I talk to people like Mick Kirsten or Gregor Casales or whatever, they say, yes, it's true, you have to have an aspect weaving API or IDE, or otherwise you can never hope to understand what your code does. And that does worry me a little bit because people, I certainly like to reason about my code by just looking at it, not by having to only be able to use this IDE. You know, I mean, I like being able to use any editor I want or whatever. So those are just sort of some of the things that you know, my thoughts about it. That doesn't mean that we're not interested and that we don't, you know, look at what's going on there, but it's not something that we are actively working on in C# right now.
Okay, so then my question is there anything that you propose that take an idea of AOP like cross-cutting certain things like transactions and logging that you would
Right.
think would be appropriate to apply to C#?
Right, so are there things that are appropriate of the same nature? I think a lot of the stuff you can do with AOP, you can do with hosting environments, and we certainly do already with ASP, the Indigo project that's part of Longhorn, you know, where we have attributes that describe on an object, you know, the way in which it wants to be instantiated by the hosting environment, you know, what kind of transactions guarantees do you want to have, et cetera, you know, what sort of session do you want to run in, all of those things you can declaratively put on your web service objects, and then, you know, have the activation framework pay attention to them and do the right thing when an incoming message arrives. So I think there are other solutions to a lot of the things that you know AOP does. So that's sort of my take on AOP. Anybody else?
Dynamic languages like Python and others in CLI?
Right, dynamic languages. I think dynamic languages are, I mean, one of the great things, it's great to see stuff like IronPython on .NET. I'm really excited about that. I think there's always when people say dynamic languages, when you quiz a little more, it typically boils down to whether they are typed or not. And I think there's a lot that we can learn from untyped languages that we could actually apply in C#. There are things that we're actively thinking about for the next version of the language. I could try and give you an example. For example, let's say in JScript, or just to take an example, it doesn't really matter what language, but you write something like, you know, var x equals 5. And well, that just means x can be of any type, and now it so happens to have the int value 5. But then on the next line, you could say x equals hello, and that would be fine too, because x has no type, or it has any type, and dynamically its type changes. But so there are actually two things that people like about it. There's the fact that they didn't have to say the type up front. And the brevity that comes from that. But at the same time, they end up having issues, you know, because they can just dynamically change the type, and that's not always what you want. I think, for example, take an interesting construct like, one of the things that people complain about in C# is like, if I have to write dictionary of string, customer x equals new, and now I have to say the whole thing again one more time. Dictionary of string, customer. I'll write it out. Yeah, I'm gonna run out of whiteboard here. Red. And people go, why am I having to say this type twice? And one sort of thing that we've been toying with is we could actually do a lot of type inferencing. We could allow you to say, never mind what the keyword is, but just allow you to say var x equals new dictionary of string comma customer, and we can actually infer what the type is from this side, because every expression in C# has a type. And so this could simply mean give x the type that this guy has. And that could turn into be a useful construct. There are other things that we're thinking about, like where type inferencing might be interesting, like object initializers. Like one of the things that, let's say for example you write something like point p equals new point, and then you say p dot x equals 5, p dot y equals 10, and then you call foo of p. Let's say you just had some type p that didn't have a constructor, but it has a bunch of properties that you want to set. It turns out that that's actually a very common pattern, and we're thinking about like giving you the ability to combine construction and initialization of properties into one. So you could write, instead of this, you would be able to write something like new point open curly x equals 5 comma y equals 10 close curly, like that, and have one construct that news up an object and sets properties on it, and then that composites nicely. You could pass it as an argument to a method. So that's another example. Like now, if x itself was a class, well then we could actually infer and just allow you to say open curly here and more stuff, and give you sort of nested object initializers all in one construct. So anyway, there are lots of things that become possible with type inferencing, and that's something we're thinking about, that we could actually sort of get a lot of the feel of a JScript or Python-like language. But the thing that would differ, of course, is that when you write this, x would actually be strongly typed. So you would still have x dot, you would see an add method in the drop-down, because we know what the type is. So even though it might look like script and be as simple to write as script, it would actually still be strongly typed. So anyway, I don't know if I answered anything here, but yeah.
Talk about multiple inheritance, and if we'll get it, and why we have it so far.
Right. Okay. So the question is, what about multiple inheritance, and will we get it? And if not, why? Well, the cop-out answer at this point is that if we were going to have it, we needed to have it in the first release, because it's way too hard to add after the fact. And even if we did add it, we could never mandate it as being part of the CLS, I don't think, meaning that every language can support it. Because, I mean, multiple inheritance in VB, I just don't think that's a great cocktail. And so if we had multiple inheritance, if it wasn't usable in APIs, I wonder how useful it would really be. I think also when you analyze what is it that people want to do with multiple inheritance, in the vast majority of cases, I think there are simpler answers than the full multiple inheritance enchilada with virtual base classes and the diamond problem and all of that stuff. One thing that we've been thinking about, that I'm not making any promises, but is the ability to have default method implementations on interfaces, which could give you a lot of what multiple inheritance or a lot of what people often want to use multiple inheritance for. One of the things that people often complain about with interfaces, and there's sort of like this tension in interfaces between the implementer of the interface and the consumer of the interface. The implementer wants the interface to be as small as possible, as few methods as possible, right? So it's easy to implement. The consumer wants a bunch of helper methods, that, like, let's say the work is done in a method with 10 arguments. Well, you want overloads that take fewer, and you want helpers that validate the parameters first and so forth. But there's no place to put those on an interface, because you can't inherit the implementation of those. And so people use abstract base classes for that sort of thing, because you can but then you lose the ability to multiply inherit. you could imagine a world where we permitted methods on interfaces and gave you inheritance, but still permitted no state on interfaces. The minute we do state, then we get in trouble with the diamond problem and whatever. But there's actually sort of maybe a meaningful ground there that we're looking at. But I'm not making any commitments, but I think it's interesting to speculate about. What's that?
You just allowed like privately inherit, not publicly. So just inherit.
Well, you could privately inherit, but that still only gives you a single pivot of inheritance. I mean, so with if we permitted code in interfaces, then you could multiply inherit. Truly, you could inherit sort of a default implementation and whatever. So there's some interesting. What's that? It's not quite like mixins, because mixins can have state as well. But mixins are interesting too. And that's another possible angle, and I don't know where it's all going to pan out. For those of you who don't know what mixins are, let me just sort of give you an idea of what a mixin is. Let's say you write something like class printable of T inherits from T, and then you write some code. Today you cannot write that. If you could write that, then you could actually pretend to get something like multiple inheritance, because imagine here, for example, I have a public void print method. And let's actually say there's an implementation of it here as well. Now I might, for example, say class myForm inherits from printable of form. And then my code for my form. And what would happen here is that my form inherits from printable of form, which would inherit from form. And so I've essentially sort of jammed a piece of code in between myself and the base class and inherited some methods in the process. And it's something that we're looking at. It's unfortunately, doing this in the CLR is non-trivial, because today, because you cannot inherit from a naked type parameter, the CLR knows a lot more about the layout and structure of the class. The minute you can inherit from anything, as a type parameter there, then we need more indirections in our code generation, in generics and whatever, and then the world becomes somewhat more complicated. And so it's not clear which way we'll go with this stuff, but I think we know of most of the alternatives. But if you know of others that I haven't heard of, then please ping me. Yeah. Why is there no is numeric on a string? Well, I'm not sure that it would be appropriate to have that on string itself, because then, why is there no is date and is blah blah blah, and so where do you end on string itself? But I think it's very valid to ask, why is there no method that you could call that says, is this string a number? And in fact, we have added a new method in Whitby, or several new methods. So on all of the primitive data types, like int32, for example, and double and float, and all of those guys now have a, see if I can get the signature right, I think it's public static bool try parse of string s comma ref int x. I think it looks like that. So there's a method now that you can call. I mean, the call would then look something like, let's say you have string s equals something or other. You would say an int x. You would say if int dot try parse of s comma out x. Sorry, it's not ref, it's out. Do something. So this is essentially your method, yeah. Now this has the nice effect of also giving you the result if it is a string. So you can make an is numeric out of that very easily, without having to catch exceptions. Yes, and I should have said that up front, yeah, yeah. So that's there now. Yes?
To talk about out, why did you decide to use in parameters as real const parameters coming in?
Why did we?
You chose out, which was good. Is there any reason why you didn't use in C#?
Why we do not have the word in?
As in parameters?
Oh, why you? Okay, so the.
Const, yeah, for read only.
Okay. So So are there two questions? Is it why?
Why is it that you decided not to implement an in?
Okay, but an in is not necessarily the same as a const.
Right. Like an in or read only.
Okay.
Right.
Yeah. Well. So first of all, we don't make you say in on parameters, but by default parameters are in, so to speak, that they get copied. Now, of course, if the type is a reference type, then you are still aliasing whatever you're passing as an argument. And are you asking why we don't have read-only parameters also and const and so forth? Well, that was another big debate that we had like way back at the early days of .NET. Should we have const like C++ has const? My feeling, and I think it still holds, back then, and it was shared by the other team members too, is that the only reason const works in C++ is because you can cast it away when it's inconvenient. But it would be odd for us to have a notion of const in the runtime but not enforce it. Because I think once you're in a type-safe language like C# and in a type-safe runtime environment, people expect us to make guarantees. If you say const, they would expect it to truly be const and for us to check that you don't violate it. And once you batten it down and literally say, once you're const, you're forever const, you very quickly find that you sort of have to create a shadow gray world, a const world. Like you have to have a read-write list of objects and a const list of objects, and then so you just sort of end up pushing this problem ahead of you, and everywhere you go it spreads. Do you know what I mean? And you need the entire world to have a const version also, and it just ended up not being practical. So that's one reason. The other reason again is that for a concept like const to be useful, we would have to allow you to use it in your APIs. Well, that means every language on the .NET runtime has to support const, including VB and JScript, etc. Else, again, there is no guarantee, right? So what's the value? And so when you factor all of that together, we just concluded that, much as we'd like to, it looked like we were just, trading one set of problems for another, basically.
Well, with the out parameters, then, are you allowed to read that?
Okay, without parameters, are you allowed to? No, we basically have in C#. So let me erase. There are three kinds of parameters. So there's input, output, and in-out, if you will. Well, it's actually not in-out, it's by ref. And you can sometimes view them as in-out, but they have aliasing semantics as opposed to copy in-out semantics.
Right, because when you make a change, the change is made immediately.
Yes, immediately, yes. And so this is, you don't say anything on your parameter, it's input. If you say out x, and here if you say ref x, you get a reference parameter. VB allows you, someone asked me earlier, VB allows you to pass a property by ref, and they synthesize a local variable, pass that by ref, and then copy in and out of that local variable. But of course you don't get the aliasing semantics, so when you actually modify the variable, or what you think is the property, the modification doesn't happen until you return, which can be surprising, and for that reason we decided not to do it automatically, but rather make yourself be explicit about it and and do the copy in out manually.
But with an out parameter, can you read that?
No, an out parameter on entry to the method. Well, so first of all, at the call site, an out parameter does not need to be definitely assigned before you pass it. On entry, it is considered not assigned, and you must definitely assign it in all code paths, or else it's a compile time error. And after a call with an out parameter, the parameter is considered definitely assigned.
But can you then still access it and use it on the right-hand side?
Where? Inside the method?
Inside the method.
On the right, yes, once you have assigned to it. But you must assign before you use, yes, because there's no guarantee going in that you're definitely assigned.
And is it implemented via reference?
Yes, yes, it is essentially out and ref are both done by ref. Indeed, the runtime actually only supports by ref, and then we have an attribute that we pass on the argument to say that it's out. Yeah, louder? You're kidding me. I can't be any louder than that. How many can hear me? And who cannot hear me? Well, they could hear me, could they? That was a trick question. Okay, I'll do my best, but this is as loud as I am. Sure.
I have a question about pedagogy.
Yeah.
I teach this language, and Visual Studio Environment makes it very difficult for students to take examinations. Because when they type, they get IntelliSense pops up, there's an answer. They don't have to remember anything.
Yeah.
Java, they have to remember something.
So you mean we should make it as hard as Java? Is that?
I just wondered if you had any thoughts on pedagogical approaches to teaching this language to. These are not new programmers. They've had object-oriented programming. They've done C, C++, some have done assembler. So any thoughts on that?
Well, I mean, my initial thought is that I think it's okay, actually. I mean, it's kind of like, can you bring a calculator to your exam? I mean, what are we teaching them? Are we teaching them how to add numbers or the bigger problem, right? I mean, and I think it's all right to use IntelliSense, and then, I mean, but then make the exam harder, and just assume that they're using IntelliSense to answer the rote memory question. Do you know what I mean? And make them actually think about the algorithm instead. So that would be my initial thought. Is I don't think that you gain much by forcing them to memorize, and that's really all that IntelliSense helps you with. Yeah. Yeah.
I have a question about defaults for parameters. That's not in C#.
Right.
And instead you have to do the overload.
Yes.
Not too big of a deal, but the real problem is when you've got XML documentation, you copy that through all your overloads, and if you need to make a change, you now need to change that. I'm just curious as to why the default parameters were not in C# and
Okay.
if those might show up in the future.
Okay, so the question is why don't we have default parameters? I think there are a couple of reasons. First of all, they're somewhat duplicative of overloading. I mean, you can do the same with overloading, and which is indeed what people do today. But yes, you're right, it's more typing for sure. I think the other one is subtler, and in retrospect, maybe not as important as I thought, but originally in the language design, our issue with default parameters is that they burn the default into the call site, as opposed to leave it up to the implementation. If you do overloads, let's say you have void f, and then let's say you have void f of index, for example, and void f of index is where the work happens, right? And then in this guy here, you simply say f of 5, because your default is 5. When the user calls f, it is up to you to change. You can change what your default is later in v2 of your API. Oh, sorry. Thank you. Oh. This actually, by the compiler, is translated into f of 5 in the call site, because it just copies that value, and now you can never change the default. So this gives you more flexibility, but and I thought that was important. Perhaps it's not all that important, but
That only affects me if I'm not compiling that bit of code right there in version 2.
right. I mean, this is assuming this is in a library and the calling code is elsewhere. Yeah.
I understand.
Yeah. So that was the thinking around that. I mean, when you combine that with the fact that you can do it with overloading and, you know, where do you stop feature-wise? Do you know what I mean? But
So my problem is I've got these XML doc comments that are duplicated. I just, you know, strip off one. I guess it would be a neat language feature to be able to somehow indicate this is my primary, my big method, right, with all the parameters.
Yeah.
And then the other ones are just going to borrow that XML doc comment, like an XML doc comment.
yeah, okay.
There, so
Now that I think that's not a bad idea. That they should be able to share the documentation. I can sympathize with that. What's that? Oh, okay, the not bad idea was the ability to share the XML documentation for all of the overloads. Because today you have to duplicate it. Any questions over on this side here? There's one.
IDE question is C# can a plan have the edit and continue?
Edit and continue. It could happen. I mean, obviously, we're putting in place a bunch of machinery in the CLR and in the IDE and so forth that C# could leverage as well. So I wouldn't. Don't be too surprised to see it sometime in the future. Yeah. Yes.
Is there any mechanism that allows to pass functions as parameters? I'm not clear about delegates. Is that what delegates does?
That's what delegates do. Yes. So the question is, how can I pass functions as parameters? And the answer is delegates. Yeah. That's what they're for. And anonymous methods makes it even more convenient in C# 2.0. Yeah.
You're talking more and more about declarative stuff. Do you see some influence of declarative programming like Prolog on C#?
Right. Right. So the question is, it seems I talk more and more about declarative things. Do I see more of an influence of declarative programming on C#? I think the answer is yes. I mean, there's only so far you can go imperatively, right? I mean, if imperative is all about not just saying what you want done, but how you want it done. And it seems to me that there's only so much more we can do imperative-wise, but declarative is like wide open, right? I mean, there's no end to what you could possibly do declaratively, where you make the users not so much say how they want it done, but just what they want done, and then have the machine figure out how to do it. And you see sort of a trend in C# 2.0 that a lot of the language features that we provide are actually sort of synthesized underneath as certain code generation patterns that are commonly used, like anonymous methods is one example, and iterators is another. And I think that you should expect to see more of that, because I do believe that that's how we add value as a language, is we codify common patterns and then generate the appropriate code for them. So yeah. Yeah. Well, singleton is, well, you never know. I had not thought about like codifying that one, although sure, you could envision something like that. Yeah. Yeah. What's that? Well, begin and end transaction, actually, that's thanks for asking, because that one you can already do, I think, almost at least, and so. Well, no, not so much with closures, but with how many of you use the using statement? And so one of the things you can do with the using statement is you could declare something like struct transaction, and then you have a public transaction of arguments, and do begin stuff. And then public void dispose end stuff. If you write a little guy like that, you can actually use that by then saying using new transaction of blah, do stuff, curly. And be guaranteed that this method is called on the way out, no matter what. And you'll note that I implemented it as a struct. A lot of people are not aware of the fact that you can implement these as a struct and that it's actually a pattern. All that is required is that you have a public void method taking no parameters on the type that you are using in the using statement. And this essentially will just set aside a little bit of memory on your stack, right, to hold whatever state you have in here, execute your begin code, and guarantee with a try finally that gets synthesized here that the end code is called automatically. Now, that said, transaction is actually the one pattern that is a little bit tricky to implement because you can't tell, so to speak, in this dispose guy whether you are committing or rolling back. Now, so for transactions, I mean, the best you can do with using right now is if you have a public void commit as well, do commit stuff. And then actually, well, what you would do then is you would say up here, you would say bool committed. And then in here you would say and then in here you say committed equals true, and you do whatever you need to do to actually commit, right? And then you require that people say, and at this point you've got to modify it a little bit more. Like so, and then you say t.commit here. So this means, you know, you have to remember to commit, and if you don't commit, then you get rolled back. Because this guy, the dispose that is always called, can now tell whether you were committed or not. Now we've thought about whether we could codify this again as a language construct a little bit more, you know, and essentially allow you to tell on the way out whether you are exiting because of an exception or because of normal flow of control, which is essentially what you kind of want to know. And that's not there in the language, but you can do it like this now, and certainly not have any heap allocation overhead and so forth. Yeah?
So could you put that dispose logic at the end of the using statement?
It gets put there automatically for you. That's how the using statement works. I mean, essentially, this gets transcribed into a try finally. This becomes t equals blah, try, do the code, finally, t dot dispose. So this is the translation that the compiler performs for you. It's just shorter. And so you're guaranteed, no matter how you get out of this code, I mean the ... being the code that you had here, right? No matter how you get out, the dispose method is going to get called.
So right now you can't tell how it got called.
But you can tell whether it got called because someone threw an exception in here or whether they just fell out the bottom. And that's why you got to require them to call commit. Yeah. Yeah.
question about enclosures. When you're talking about anonymous methods,
Yeah.
you mentioned that it generates an internal class, and it had a member property,
Yeah.
and it copied the value over because of the type.
Yes.
And is that just to allow that to go out of scope when the method is done? And what happens if that's a ref type?
Okay. So, a question about how do closures work with anonymous methods, and so maybe I'll try and see if I can whiteboard an example of it, and then show you the transformation that happens. So let's say I'm just going to pick a contrived example as opposed to a bigger one. But let's just say I have a delegate type. Let's see, int d. So I have some delegate type that is a function returning int. Now let's say I write void, df of Okay, so let me first explain what this does. So what I have here is an anonymous method that returns the value of x and increments it. Then I have a function that returns a delegate returning int. And this anonymous method is returning int. So what actually happens when I do this piece of code here is that this gets hoisted and becomes a little method, and I'm returning a delegate to that little method. But now, let's say I write code like d equals f. And then afterwards, I start calling d several times. Or actually, let's say I do of d, and let's say I do that again. So this one will output 10, this one will output 11, 12, as I keep going. And so the question is, how the heck does that work? Because what I'm doing is essentially I keep like returning this local variable, but this function has already returned, so where the heck is the local variable at this point, right? You sort of see the dilemma. Now, the way this actually works is that we translate this code when this is called capturing a local variable. And when you capture a local variable, we have to extend the lifetime of that local beyond this function. So what we do is we create a class with some name that doesn't matter. And in here, we put an int x. Then we also put a int f. So first we create this little helper guy. And then we change the code here, essentially, to say, or let's call this class here underbar local 1 or whatever. So underbar local 1 equals new. And then we say, well, X is a bad name here. Let me just, sorry. And we say locals.x equals 10. And then we say return new d of so that's essentially the transformation that we perform on that code. So we create the helper object, we move the local variable into a field of the helper object, and then we move the code into a method and refer to the field, and then we create a delegate to that method. And so essentially what you end up doing, it's almost like your function actually ends up sort of declaring a little class and putting all of the captured variables into local variables in your helper object, which turns out to be very useful when you're doing these functional programming language-like things that closures allow you to do. And this is like a lot of the rave about Lisp and functional programming languages is about the ability to do precisely this. Now, you'll note here that we've done it with L-value semantics, meaning that we actually capture the location as opposed to the value of X, and therefore we allow you to modify it. Another possible implementation would have been to just capture the value like Java's anonymous methods do, or anonymous classes do, but it's not nearly as expressive, and it's kind of surprising, you know, because we are an imperative language, and variables, you're supposed to be able to modify them, and you know, this notion of final variables or whatever is kind of strange to most people. So anyway, that's kind of, you know, a contrived example, but again, if you, I should put up actually, if you're interested, go to go here and grab the C# 2.0 specification, which has a bunch more examples about how this can be used and how it's implemented.
What's the lifetime of locals?
Well, the lifetime of locals here, since it's a class, goes away when no one else references it anymore. So the delegate ends up keeping this guy alive, right? And so once you let go of the delegate, i.e., once no one can call you anymore, then the GC takes care of it. Yeah.
Use of for each on intellection versus traditional for loop and indexing and intellection, and how will iterators affect that?
Right. So my thoughts on for versus for each and the efficiency, I suppose, is what you're asking. Well, generally, my answer is always use for each if you can, because chances are you will have fewer bugs if you use for each. There are just more pitfalls with the regular for statement. It is true that in some cases the for statement is more efficient. I think the vast majority of cases, I don't think you would ever notice. And so my advice would be always use for each, profile your app. If they turn out to be your problem, then change them to for statements, but I don't think you ever will in real code. And I think for each is much more expressive. And actually, in theory, allows us to optimize your code more in the future. There are certain optimizations that we will do because we can tell that you're going over the entire collection and whatever, and so we could, at least in theory, you know, generate even better code. So I would highly recommend for each, unless you really do need the index. Yeah?
For the convert statements, I've been told that rather than putting like a dot to string or to inquiry to, you should do the convert dot for optimization.
Yeah.
Is that anything that
So the question is it okay to use toString or should I always use the convert class? It doesn't matter. And honestly, it's a bit messy that we have both. Convert the intent is that it's sort of like a one-stop shopping for all your conversions, because it goes from everything to everything. And so in that sense, you know, it's certainly easier probably to find the method in the convert class, but performance-wise, there's no difference. Yeah.
Any chance to have a width block?
The width statement. Is there any chance that we'll have a width statement? Well, I guess there's always a chance. We keep getting asked. I keep resisting. I think if we were to do something like the type inferencing I talked about before, it actually starts to become very convenient then, I mean, because, let me keep that. Because you could now say that, you know, I mean, let's just assume that there was a with statement, right? And you would say with foo, and then, you know, dot x equals 1 and dot y equals 2. You could certainly speculate that if we had type inferencing, you could always, almost like in a machine-like fashion, just translate this into var x equals foo. Well, assume, of course, that foo is something very long, right? So blah, 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 blah. And then just x dot x equals 1 and x dot y equals 2. And I mean that the idea here being that you would actually never have to worry about the type. You wouldn't actually have to say the type name because we could infer it. Do you see what I'm saying? So, but I understand that it's not precisely the same, but it gets you a little closer. With this less typing, yeah. And there is also the issue, I mean, the very pragmatic issue actually is that we would break a whole bunch of code if we added a keyword with. So we got to be real careful about that. I know I'm just making up excuses here, but but nonetheless, you know, I feel strongly that we want to try to make the language be 100% backwards compatible every time around, and so we got to like be innovative about how we would do that. But it does come up, and maybe it'll come up enough. I don't know. Yeah. Yeah, so iClonable is this funky interface that we have in .NET that has a clone method, but the contract is not clearly specified. In particular, it doesn't say whether it does a deep clone or a shallow clone, and therefore, you don't really know what this method is going to do. It's sort of, yeah, it's a problem, and it is inconsistently implemented across the board. I would say that I think the only sort of, I mean, the strange thing about cloning is that it's very related to serialization also, and you know, I always felt that the only way you can guarantee that you can clone a web of objects today is serialize them and then deserialize them. And now you know that you have a clone. It is unfortunately too late for us to tighten up the contract of iClonable, and I'm not sure that we're going to implement another iClonable at this point. But it's something that is being actively debated, not so much in C# but in the base class libraries. But so far, yes, you need to roll your own, unfortunately. Let me just see, are there any? Yeah.
Where would you like to go with generics?
Where would I like to go with generics? Well, I think the mix-in stuff is one interesting angle. I think one of the things that we've sort of discovered with generics is that even though our constraint system is fairly rich, it could be even richer. There's a lot of sort of pattern-like programming that you can do with templates that our constraint system is not rich enough to express. Like, I mean, it would be nice if you could declare a pattern like a number. A number is, you know, something that has a plus and a minus operator, et cetera, et cetera, et cetera, and then anything that meets that pattern could automatically be used as that type parameter, if you follow what I'm saying. Our constraint system is not rich enough to do that right now, so it's something that we will try to look at. Unfortunately, it brings about a lot of complexity as well. Another one is dynamic constraints, which is the ability to, well, dynamically check and constrain something that is of a generic type. Yeah, I think it gets a little out in the weeds to do an example right now, but there are a lot of things that we're actively thinking about. And of course, I mean, I'm always interested in hearing feedback on what you guys think we ought to do more with generics. I think we have specifically proceeded with caution in this release and not, you know, I'm always a believer in if you don't know exactly what you're going to do, then don't do anything, because then you can always figure it out later. a lot of, I see over and over, I mean, be that in programming language design or API design, you know, sort of the mad land grab to put in abstract classes for everything that I ever thought about, right? And then in V2 or V3, I'll fill it in, you know, and then I'll write all the implementations. But of course, once it comes time to write the implementation, you realize that your abstraction is wrong, but now you've shot yourself in the foot by already putting abstractions in place, and now you've got to deprecate the whole thing and start over. So we're trying to be sort of very cautious about not putting stuff in that we're not entirely sure about.
Are you planning to follow like what C++ templates?
Well, C++ and templates is a very different model because it's compile time, and it has sort of a macro-like aspect to it that generics don't have, because generics are much stronger typed and are instantiated at runtime. But one of the things that we would like to capture some of the expressiveness that you have in templates, and the fact that templates do their type checking late, that is at instantiation, allows you to do sort of these patterns that I talked about. Because you can assume that a type parameter, you can do anything on something of a type parameter type, well then you can have patterns. You know, of course the error messages that you get when something doesn't meet a pattern are terrible. And we'd like to actually sort of formalize it so you could describe a pattern declaratively and then have the compiler check whether you adhere to it before it permits instantiation of the generic, I should say. So those are just some random thoughts, I guess, on the topic.
What about nullable value types?
Uh-huh.
Are there any performance considerations with the system?
Right. Are there any performance considerations with nullable types? Well, I mean, they are, of course, more expensive than just, I mean, an int question mark is more expensive than an int, obviously, because it's a struct that has both an int and a bool in it. That said, you should expect it to be a heck of a lot more efficient than boxing the int and treating it as an object, or some of the other possibilities that you know are not so great. I'm happy with the fact that nullable is itself a struct, so you don't incur any heap allocation when you use nullable types, and that will help because you don't add memory pressure, and they're fairly storage efficient compared to boxing and so forth. But again, I would always sort of urge you to profile, but I would expect performance to be pretty decent with nullable types. Yeah.
This morning you showed your iterators, how it expands the code
Yeah.
to like a statement sheet. You see that it's growing the footprint much, right? Or growing memory footprint? Looks like it gets large.
Sure. So iterators, I showed how this morning that they are one of these expansions that we do, and here's another one, right, with anonymous methods and so forth. And well, let me ask one question first. Do you mean expanding the footprint compared to if you wrote it, or compared to what?
Well, typically with an iterator, if I'm just moving to the next one in the list, it's a simple command of an internal variable and returning something. Whereas it looks like you're building large switch states.
Yes, yes. Okay, now I understand. But see, iterators they're not the same as a for statement or a for loop, so to speak. In a for loop, you are incrementing an index and then going back and indexing into the collection, so to speak. And with an iterator, it's the collection itself that controls what gets produced as you iterate. And there's actually code. So you are asking the collection to yield the next one and the next one and the next one. So it's a different model of iteration. One of the things that iterators allow you to do is lazy evaluation. Someone asked a question in my talk. The iterator can produce the results as you go, and if you break out of the loop, it doesn't have to produce the remaining results, which is really interesting when you're dealing with, in particular with infinite series, like, you know, all the prime numbers in the world. Well, you could write a prime number generator as an iterator that will never stop. It stops when you break, and if you never break, it just keeps on going. But it doesn't mean that you first had to consume infinite memory to produce all the numbers. So there are interesting programming paradigms that become possible because of lazy evaluation that you otherwise couldn't do. Now that said, I mean, I think in general, like simple iterators will be very efficient. And I would not expect there to be, I mean, there will be some performance difference if you're really counting clock cycles, but it's pretty dang efficient to begin with. So, let me just, yeah.
Regarding nullable types,
Yeah.
if I have a method that takes in an object and I pass in a nullable type that's null, is there magic going on where inside the method I can compare that to null, or do I have to cast to a nullable type and then compare?
Right, right. So what happens when you pass a nullable type as type object? Well, the nullable type gets boxed. And this is sort of, it's one of those places where you're damned if you do and you're damned if you don't in terms of your design choice, because it's a little odd that well, let me show you the code and then you'll sort of see what I mean. So if I write something like int question mark x equals some value, let's just say 5. What I'm actually creating here is this is the same as saying nullable of int 5 or int x equals new if you will. You know, this really is what that does, right? And nullable is a struct, so you know, schematically in memory, what's happening is that, you know, I end up with something that has the value 5 and the value false. Or sorry, the value true. And this is the value property, and this is the has value property. So nullable is just a struct that has two fields. One of type t, which in this case is int, and one of type bool that says whether or not the value is there. And so when you declare a variable of type nullable, you get a little struct with two fields, the value 5 here in this case and the value true, meaning that it's not null or it has a value. When you now say object x or the object y equals x, what happens here? Now two things could sort of logically happen, right? We could either take the value 5 out of the nullable, put it in the heap and create a reference to that. That means, in other words, unwrap the nullable and box the 5. Or we could box the whole nullable. Now, for reasons of backwards compatibility, we do the latter because that's what we've always done. And that's what other languages will do, and we can't change the rules midstream. But it is, and you can construct scenarios where one is meaningful and where the other is meaningful. But it's good to know that exactly what happens, which is we box that guy. So we actually end up then at this point here creating in the heap some object that is, you know, tagged with a type that says nullable of int, and then contains two fields, the value 5 and the value true, and then this guy points to that boxed object. That's what ends up happening. Now, of course, the advantage here is now later you can tell that this is a boxed nullable as opposed to a boxed non-nullable, and so.
So if you were to compare y equal null, then there's no magic.
Yeah, there is no magic that, yes. And this is the thing that is perhaps where it starts getting a little confusing, right? What if I say object x equals null? And then I say object y equals x, right? What's that? You still get the box with, yes, with a null value in it. But yeah, but that's the one. Now, for that particular, you can actually, there's a method that will do the other. So you can write if you do it this way, there's a generic method on a class called nullable that will do the other thing. So this will unwrap the value 5, or it will return a null reference if x is null, or otherwise it will return a boxed value 5. Now in reality, you don't really run into this at all. I mean, so this is just sort of an interesting corner, but it's not really something that happens in mainline code. Mauro? What's that?
What about a BCD type? Any blanks?
A BCD type? Well, the decimal type is there a reason why decimal doesn't work, or why it doesn't have enough digits, or? Well, that I don't think is true, because the decimal type is every bit as good as a BCD type. It doesn't use BCD encoding, but it uses a scaled int, which has the same effect. You don't get round-off errors with decimal. Yes, it does do Banker's rounding. Yeah, we should talk offline, because people sometimes ask about BCD. There are many. The thing that's interesting about BCD is not the fact that each digit is stored in tens encoding. It's the fact that it's a tens exponent encoding as opposed to a 2 exponent encoding. So the decimal type actually squeezes a little more storage by storing a large scaled integer. But the rounding characteristics are the same. You don't get rounding errors with decimal. But let's talk after. I'll show you what I mean. Just make sure that, yeah, go ahead.
When you're talking about boxing there, I haven't done C# in a little while, but I remember reading a boxing and non-boxing potential problem when you have structs that automatically get boxed, say an array list, and then if there's a member function that you call that has a side effect.
Yes.
Still there?
Yes, that is still there. I mean, it can sometimes be a little surprising what happens. Yeah.
It's fine for arrays, but you use an array list or something that takes an object.
Exactly. Yes. Let me show you okay. Sorry. The question is, there are some issues with boxing and mutable struct types, and I'll show you what the issue is. In fact, Peter Goldie, that used to be on the compiler team, wrote a blog entry about this a while back, where he was saying mutable struct types considered harmful, like a take on Dijkstra's gotos considered harmful. And there are some weird things that can happen with. But let's say I have something like struct foo int x, and then let's say I have a void set of int value. Let's just say I have a little mutable struct like that. Now let's say I write code like var x equals var foo. Well, I guess I should have a public foo x equals 0. Okay, so var foo f dot set of 5, f dot set of 10. So I can call this method and mutate my struct. The reason I can do that is actually that inside a method of a struct, this parameter appears to be of type ref foo. That's how methods on structs work. So they take a ref foo as a hidden parameter, if you will, this parameter, and therefore you can mutate by reference the guy that you called on. And therefore, when I do f.set of x, if I then now say console of f dot x, if, well, let's say it was public, I will see the value 5 being printed. Now, let's say that instead we have var, sorry, I was saying bar f, I can't say that, of course, I have to say foo, but let's say I say foo array fa equals new foo array of 10 or whatever. And then I say fa sub 0 dot set of 5. And I then say I still see the value 5 being output. What I'm doing here is I'm actually passing by ref the address of fa sub 0 and then jamming the value 5 into its field. Okay, so now is where it gets funny. If I instead say list of foo fa equals, let's say I determine, oh, I was using an array, but I'm going to use a list instead because I want it to grow automatically or whatever, and I say new list of foo, like that. And let's say I say fa dot add of a new foo, for example, and then I say fa sub 0 dot set of 5. Now my output, unfortunately, is 0, which will probably surprise some people, but if you dig a little bit, you'll see why. So what I'm doing here is I'm invoking the indexer on fa, which is actually a method, because a list has a setter and a getter on its indexer, right? This returns me a foo, and then I call the set method on that foo, which is a copy, and I jam the value 5 into something that I then proceed to throw away, and then I output the old value, which was 0. Now, what this all proves is that I think Peter is right, that mutable structs are considered harmful. There are some surprising things that happen with mutable structs, and it's not clear what we could do here. I mean, other than maybe forbid you from having indexers and therefore growable lists or things that can be indexed, and that's not a great solution either. It would be unreasonable to say that this is invalid, because, I mean, well, you know, it's perfectly valid to call have a mutating method. It's just you got to know what's going on. It's just one of those unfortunate corners that you end up in. I think what's that?
I mean, if you return a reference to the cell within the list, then you could mutate.
If you returned a reference to the cell in the list, yes, but that's not type safe.
Even with the
well, it is if it's heap. It is if it's heap allocated. But if it's stack allocated and you had the ability to return references, then, I mean, if you had an address of operator, so to speak, is that what you're asking, or?
Well, I mean, the question. This only sort of come up because you have generics now.
Actually, no. This would come up if anything that has a property that returns a foo.
So if you made that a class instead of a struct, then you...
If I made it a class instead of a struct. And so I think where I'm going with all of this is that structs are great, but you got to be careful. They're sort of an optimization. The right way to use a struct is to make it immutable. I mean, you don't have methods that mutate structs. Create new structs if you need to mutate the value of a struct. And only in very exceptional cases should you have mutable structs, because they are considered harmful.
Do properties have the same flaw as well? Instead of an explicit set method, we had instantiated a capital X property that had a getter and a setter, but it still failed in the same way.
Yes, if this was f dot get or my foo dot set, if you had a my foo property on some object, you would see the same issue. Yeah.
You don't actually need to set it. Set isn't really the problem, right? I mean, you've got a public field X, so it's still.
Oh yeah. Well, let's say there was a get and a set or whatever. Yeah. Any other questions or comments? No? Yes? Yeah.
Earlier when you talked about partial typing, you showed an example pulled together from 2 for 1 class.
Yeah.
Can you use more than 2? So, are there considerations to how it orders them? Is it
Right.
telling you how to
Right. So the question is, with partial types, can you have more than 1 or can you have more than 2 partial fragments? Yes, you can have any number of partial fragments. There is no ordering, or rather ordering is not observable and doesn't matter, because partial merges the fragments at the member level. So we just take all of the members and smush them all together, but we don't merge within the members. If you have a method F in one and a method F in another, that's an error. So there's no merging, and therefore there's no ordering that you really observe. Because in the CLR, you can't observe what the order of your fields are, for example. It doesn't matter. The CLR will change it around and lay it out in the way it deems best anyway. So in the end, it doesn't actually matter. Cyrus?
With structs, and if you added the layout kind sequential attribute to them, you have partial structural fields in that.
Yes, would that be true if you had structs and you added layout kind sequential? I believe we say that it is, I forget what we say, honestly. I know we talked, do you remember, Anson, what do we say about that? Yeah, good. Well, I'm not the only one that doesn't remember. Something obviously happens. I think it is, we do not guarantee a particular layout at that point, so it is not advisable to use layout kind sequential and interop with partials. Not that people typically would anyway. So.
Can you talk about 2 or 3 other things that you're working on right now for the next release?
Can I talk about other things I'm working on? Not in a great level of detail, but I can sort of sketch out some of the ideas that we're thinking about. I mean, you saw that. One of the new things we talked about here today was nullable types, which have to do with sort of trying to erase the impedance mismatch that we have today between databases and general purpose programming languages. Now, if you look at that area, there are actually many more impedance mismatches. In fact, it's interesting. If I ask, generally, when we ask our customers how many C# customers use, well, let me try here. How many of you do database access in your applications?
Who doesn't?
Exactly, who doesn't, right? So to the extent that we could make that a better experience, that we could eradicate the impedance mismatches that we have between the database and C#, it would be a good thing, right? I mean, today, really, if you write a database applications, you pretty much have to learn 2 languages, C# and T-SQL, or whatever your database is, right? You have 2 completely different paradigms, objects versus relational. You have queries and set operations versus none of the above. Over on the other side, you have nullable types versus no nullable types. There's so much stuff that we could do better in that space by truly thinking about how do these things come together. What does a language look like that can do both? That's something I'm very interested in thinking about, because I think that could be really fruitful, for everybody. So I'll leave it broad like that. I mean, but it's something that we're spending a lot of time thinking about. Yeah.
Is there anything about a nullable type that would just be an alias to the class? Class that you guys are creating? Is there any actual support in the language that would just be an alias to the class that supports the terms?
I'm not quite sure I understand the question. I mean,
well, the way you describe nullable types,
yes,
is that it creates this class. Well, it's an alias to a class that supports generics.
Right, a struct, yeah.
Struct.
Yes.
Yeah. So is there any actual support in the language for nullable types that isn't just simply that alien?
Oh yes, yes there is. So were you at my talk or okay. Yeah, so at my talk I talked about some of the things that we're doing with nullable types. And there are several things like the question mark type modifier and conversions from the null literal to nullable types and lifting of operators so you can add two nullable ints and get a nullable int result, which will be null if either of the operands are null and so forth. So yes, but it's not really overloading. It's more, we call it lifting because it sort of broadly happens without you having to do anything. We synthesize it automatically, but you could compare it to operator. Yeah. And all of that stuff happens automatically over any type that you make nullable. So if you write your own BCD type or whatever, well, you can put a question mark after it. Now you have a nullable version, and you can add two of those, and we'll produce a null value if either is null, and so it all just sort of falls out. Yeah, again, take a look at the spec that's up there, and it has a bunch of examples and talks about how it works. Yeah.
Do you think any of the other implementations of the CLR on other platforms are viable? And does Microsoft have any plans to work with Symbian or help Rotor get on to other platforms?
Okay, so the question is, do I think that other implementations of the CLR are viable, and are we working with Symbian or other companies? Well, I mean, I'm not going to comment on the viability. I mean, it's obviously viable at some level because there seems to be a big user community around Mono, and people are using it for stuff. So it's got to be viable somehow. We definitely work with these guys. We work with them by standardizing the stuff that we do. I mean, everything that we've done in C# 1.0, 1.1, and everything that's in this spec. I mean, literally every spec that we have written on C# 2.0 has been submitted lock, stock, and barrel to ECMA. And the standardization process is still ongoing, and we're actively participating in it and committed to it. And I know that Miguel is busily cloning it. so yes, you know, it's happening through standardization, which I think is the avenue that we'll want to pursue, you know, because it's just the most meaningful way for everybody to have a vote. And indeed, we don't control this standardization process either. We have one vote out of many, and we do not make the rules. Yeah?
Do you think it's possible to have something similar to MapCare?
Remind me, what does MapCare do? It maps? Oh, yes, we have that one already. In fact, list of T. So the question is, what about, can we have a function like MapCare in Lisp, which I believe we call apply all in our generic class library. So so we have a system. So we have this new class, System Collections Generic List of T. If you haven't looked at it, look at it, because you're going to be using that class a lot, I predict. It's going to be as common as arrays, because it really is precisely what you want arrays to be. Growable and type safe and convenience methods and everything. That guy has a method on it. I don't think it does in the community release, but we are planning to add a method on it called apply all. That takes, I think the type is action of T. So it's void apply all. And action of T is a delegate type. So there's a public and essentially on this guy you can get yourself, say, a list of list equals, let's say, new list of int. And then you could, for example, do for, I don't know, int I equals 0, I less than 100, I plus plus, list.add of, say, I times I. So now you have a list of all of the products from 0 to 99. And then you could do list dot console.write line of x, for example. And this would be another way of for eaching on all of the elements of the list and writing out their values. So apply all essentially calls this method for all of the elements in the list, right? And that allows, well, okay, this one doesn't map. This one is just, I got it wrong here, sorry. It's not a void, it's a list of t. Apply all, yeah, and this guy returns a t, or actually, okay, I'm confusing myself a little bit. Pardon me. I was thinking of another method. The apply is not this one. It is apply all. I think, what is it called? It's called convert all. There we go. There is an apply all, which is the for, but it's the void returning. There's also a convert all that takes a mapper I think it's called mapper or converter. And it looks like this. And this guy essentially allows you to evaluate an expression for every element in the list and then get a list of all of the results of that expression. So that gives you sort of the functional combinatorics that you're, on high order functions and that sort of thing that you're probably looking for. That's what you're talking about, right? Yeah.
Before you erase that,
yeah.
Do you have any imagination for a syntax that would avoid a loop like that list.add loop and just allow you to add a bunch of variables to the list and construct it?
Yes. Yes. That's something that is not in the language now, but we are thinking about. You could imagine a syntax again that would allow you to say new list of int of open curly 1, 2, 3, blah blah blah, for example. Yes, and we're thinking about that for the next go round. Yeah, but that is specifically not there today. Where are we at? Okay, maybe I'll take one more question. Wow. Okay.
In your talk, you mentioned that you can access 2 different assemblies for the same code.
Yeah.
And it occurred to me that was a tremendous thing for regression testing as you're going from one release to the next, to be able to actually compare that those things which should remain the same are actually the same.
Yep. It's a good idea. I hadn't thought of that one, but yeah, you could use the idea of external aliases and the ability to reference 2 versions of the same assembly in your code to do regression testing, sort of in an automated fashion. Yeah, you could have a reflection-based tool that generates the tests, and yeah. Okay, maybe one last question. Yeah.
Now that you've achieved riches and fame beyond your wildest dream, what keeps you going? What's your end game? What's your final
My
vision?
end game.
The final vision, what you want to do.
I just want to make programmers more productive. I mean, I have fun doing this, as you can tell, and I think when I was talking about this big problem of like making databases and general purpose programming languages work better together, I mean, is It's a huge area, very complicated. You know, there's lots of stuff to do there. You know, it would be very fruitful if we could get it done. So, I don't know. It's just, I don't know. I like what I do. You know, I've always joked that I've never really had a real job because I've always been doing my hobby. Ever since I was out of high school, I've been writing software, and you know, and I've been fortunate enough to be paid for it. You know, but I'd be doing it anyway. So.
Don't let them know.
Yeah. Yeah. Right. Thanks. Yeah. Erase that. Okay. Well, thanks all for coming.